First, I have to apologize for my voice. I woke up today with sore throat, but I hope it won't impact the quality of the presentation. So my name is Maciej Obuchowski. I work for GetInData. I'm an OpenLineage committer for about 3 years. And we've been working on streaming for quite a bit of time now. And I want to share what we have, what we think will be the future. But let's start with doesn't work. So yeah, I have some problems with the slides, but I hope it will be fixed soon. So maybe I'll start by telling what we will be talking about. Why do we need Lineage, and what is Lineage? Why use OpenLineage, and what actually it is, and the differences between batch and streaming. And then we'll do a deep dive into our Flink integration and future plans. So what is OpenLineage and what is data lineage? And first, we can say it's a set of relationships, right? There are jobs, data sets, they process the data, and basically jobs and data sets can be anything you can think of. So they can be ML models, they can be files, they can be database tables, right? Everything can be a job and data set. And every data set has some producer, or multiple producers and consumers, and every job has some inputs, the data sets it reads, and output, it's what it produces. And this graph on the right is what people like to use in those kind of presentation, but the reality is more like something like this. And probably it's even very small compared to some of what you might see in your own organizations. So it's one of the motivations why we introduced OpenLineage. And OpenLineage is an open standard for the collection of lineage from the pipelines as they are running between different platforms. And basically, before OpenLineage, and so we're using platforms that don't support lineage, you have to connect all of those dots together, right? So you have data from warehouses, schedulers, you have scripts that gather your data, lineage from Snowflake, Databricks, and then send you to your preferred data governance tool, data catalog, some other tools that might do some other things with them, like incident detection. And the problem is that there are way more tools than you can possibly imagine, and it grows every year. So this year's machine learning, AI and data landscape has 2011 entries, I think. And basically all of those tools consume data at some point and produce and do some stuff with it. And if you don't know what actually reads data in your organization, you are in for some unpleasant surprises. Like I think Deutsche Bank had some surprises that they sent the data to some third-party institution and they leaked it. And by the way, OpenLineage is, I think, here. So we are here too. So after OpenLineage, ideal situation would look like this. So you have all of those tools that produce data, consume data, and anything that can visualize it and use it can just use the raw OpenLineage data. So how does OpenLineage specification look like? And it's very simple at the first look. So we have 3 things: runs, jobs, and data sets. And basically, job is a data pipeline, right? Job is like an ML training process. Job is anything that can read the data and write to. And run is a particular instance of that. So if you have a batch data pipeline, you have a job, and then every day it has a run, or every hour, or every interval that you want to think about. And then you have data sets, and data sets are everything that contains data. So Kafka topics, tables, object storage, everything. And then you have event that translates the state of this particular run that contains all of this data together. So that's OpenLineage. But there's more, and we have mechanism to extend all of those objects with facets, and facets are like atomic piece of metadata that you can attach to any of those objects. So run can have something like nominal time facet, which says when it should be running, right? And you can compare when it has run and when it should be running, and then maybe there is some incident relating to that. Data sets usually have schemas. It's also an example of facet, an extension. And basically, you can attach your own facets to the OpenLineage objects or use the common ones, which allows the data consumers to work with what they know, basically, the standardized facets. So why does OpenLineage process data in runtime? So basically, you can look at this beautiful photo and try to imagine that, yeah, this is like close to sunset. I can see the sun as it sets, so it has to be somewhere that has view on the ocean on the west. There are logs, and they are maybe volcanic rocks. And so it all narrows where it can be, right? And you can maybe take a look at the photo before that and try to imagine where this was, or just use the metadata that was generated when the image was taken. And it has usually an exact latitude, longitude, date, and more information about the image that you could possibly deduce from just the image. So our integrations try to work directly during the data pipeline, during the execution of the data pipelines, so we can get the most data and the best quality data compared to doing something like running scripts after or parsing query logs. And OpenLineage is not like a single event. OpenLineage is a life cycle of a run, and so when a job starts running, we send start event. Then if it's a long-running job, we send some running events with maybe some partial progress, and then at the end, the job completes or fails, or something kills it, and then we send an information about that. So that allows you to track the state if your consumer allows to do that. So, and OpenLineage community is growing, and it's already pretty big. We have a lot of integrations with producers, consumers. We have great integration with Apache Airflow, with Apache Spark, with dbt, and some great consumers like Atlan, Google Cloud, Astronomer, and open source tool Marcus. So next, let's look at streaming. How does what I said match the streaming universe? And I said about runs, jobs, data sets, but like if you're running a streaming job, it can possibly be unbounded, right? It can never end. But in reality, streaming jobs, even long-running streaming jobs, often stop because you have to upgrade your Flink version, or because, I don't know, something has been bugged. You have to push your new version of the code that was that's used to process the data, or you just have a new column, you have to include it in your SQL job. So all the metadata that we collect for the runs is still relevant, even if it's a long-running job. Another information is when data sets get updated, right? So if you have something like a Kafka topic, it gets continuously updated. So it's not something that is coming naturally to something like Kafka, but in some cases, like iceberg tables, you can have an explicit versioning for the data sets. So any like committing data to a data set, to iceberg table or data lake table is gonna leave a particular piece of metadata and an explicit version. So even if you're running something like a Flink streaming job, on every checkpoint, you will have a new version of the data set, and the metadata that we can send can correlate with the particular dataset version. So in some cases, we have an explicit dataset versioning, and the datasets get continuously updated during the runtime of a job. And yeah, how do we do that, right? So update on each row would produce like more metadata than actual data, because yeah, it's pretty much impossible. And we can't do this on the update on job end, because for a job that runs weekly, you will still have a very old information if something else is running this Kafka, reading from this Kafka topic. So the natural thing is like a checkpoint in Flink. But it's also kind of finicky, because some people might use very short, some people might use very long checkpoint intervals, and it's usually pretty specific to the nature of a job. So you have something like people setting the some particular updates on checkpoints. So we think it's best to like decide the job author to configure that emission interval separately. And that's where the additive, not addictive, database model works well, because you can just emit additional event, and the data for this job will be taken from the last event, in addition to having a separate information that might be not updated from the previous events. And for Spark, the natural candidate seems to be microbatch, and I think that's what we're going to look for later. And other stuff that is different during streaming jobs is dynamic transformation modification. So if you have something like Kafka source, it can find new topic during execution when posting a wildcard pattern, and we can like, catch it and emit, hey, we're reading from the new topic or partition. So this is also something that where the OpenLineage model excels and allows us to send continuously new information during job execution. So let's kind of change gears and show some code and show some, as it's open source project, I can show some particularly bad things and say that everything will be good at the end. So, oh yeah, we have some demo due to some technical problems. I will not show it here, but I can show it later if somebody wants. It would be live demo, so it's often prone to failure. So maybe it's good that I don't show it here. So OpenLineage is Flink integration, right? And it relies on some Flink integration, Flink's interface, job listener, that kind of notifies us when the job starts, ends, and the integration supports multiple connectors like Kafka Iceberg, Cassandra, JDBC, and as I said, it notifies you when the job starts, ends, and on some particular interval. Sends some additional metadata, like the schemas of the data rate, how much data was processed. Yeah, but it's like sometimes the stuff is more complex underneath. So it has some limits. There's no SQL or table API support now. You have to manually attach it to every job you do, because it requires to get an execution environment, and if you don't manually attach the job listener, it just gets the like empty constructor. So we don't actually know what job is running then. And so it's not ideal for a use case. We would prefer to do something else, but there are even worse things, like a lot of reflection. So Flink API wasn't made for the use case that we're using it for, which is like looking at the transformation that occur, sources and sinks, and getting some information from insights, right? So everything is private, and we have to work around a lot of those weird cases and just check if we can get some data, use reflection, basically. Those are the class internals. And we would prefer to have a better API for that as well. And we have some very evil hacks. And when you basically start a job, the code that translates what you wrote in the Flink job code, it's translated to internal Flink structure called string graph, but then it clears the transformations that had been occurred, and then it calls the listener, right? So it's not ideal because we have the listener, we've done a lot of work, but then we can't get the transformations. So what we do is on start, we replace the list that contains the transformations with our own list that allows us to get the information later. And that's very suspicious, I would say, solution, but it works. So why do we bother creating integration with that much limitations? So first, it showed that it's possible, and for a long time, nobody even bothered with like Lineage from streaming jobs, or done it by scripts, looking at query logs, and there was no good option for someone who wants to have the information from the source. And second, and it provides some value for our users right now. And the long-term solution would be to show this to the Flink community and say, hey, we can do something better, right? We can have an API, show what we've done with other integrations like Airflow, like Spark, and then discuss the community the better solution, because it's also an open source project. People usually are nice to each other there. And yeah, it's something we've done before, right? So, but then we didn't have that much time. It waited in the state a bit, and in the meantime, somebody else created the Flip 314, and it's called Support Customized Flink Job Listener. And it basically, it was created by ByteDance, people from ByteDance, which is the TikTok company. It has the new API, Job Status Change Listener. It contains structure called Lineage Graph. And it has both data streams, SQL table support, no attachment problems, no limitation around like SQL or table API that we had. So it sounds perfect, right? Well, let's look at the interface. And it contains like basically sources, sinks, and relationships between them, right? This is what we need. But the problem is that it doesn't contain actually the information about the data sets that are produced or read from this particular implementations of this interface. So you have something like Kafka Lineage Vertex, which is an implementation of this API for the Kafka connector. And so to do that, we'd have to do something like check the instance of, is it a Kafka connector? Yeah, then do something for the Kafka, right, in our own code. And then if it's Iceberg, do something else. And that's like what we should have to do with for everything that can produce and read, for every connector, basically. So those are not the only connectors, right? The open source ones. There's a strong culture of like writing your own connectors. I've done this myself. And Maciej Briński on the audience knows what it was for. So basically, we couldn't support something like this, right? Or do some very weird reflection. So we're getting back to the start, right? Where we check for some known table names, namespaces somewhere, and try to deduce what data it might produce. But then there is an even bigger dimension of a problem when something changes inside the connector, right? So we know that some table name is somewhere there, but then they rename the field. And we have a single connector, and we have to check, is the field there, or should we look at some other field, or maybe check the version of the connector and decide based on that? So this is getting really, really complex, right? And every implementation of this interface would have to implement such methods if they wanted to get the data for all the connectors. So the solution, as I said, in open source, is to find the solution with other people, community. Talk to them, open discussion, and that's what we did. We talked to the people. The proposal's already accepted, but they haven't yet committed any particular code. So we basically spent some time talking to them and found a solution that basically fits everyone's needs. And there was a vote, it was accepted, and the resulting API is really nice. So the only addition, really, was to create this Lineage Vertex interface. And it contains the data sets, right? So then the data sets is name and namespace and some facets. which is directly inspired by the Lineage OpenLineage facets, and then the whole implementation on the left is moving to this stuff on the right, because the connector basically knows what data it's reading and writing to. So we just have to possibly get that implementation and map it to our own class. So yeah, that's great. And yeah, the facets that Flink has now are very similar to, it will be in some next release. It's not yet released, but it's very similar to OpenLineage facets, and they can contain stuff like data schemas, right? And Flink has its own set of those predefined facets, and yeah, you can use it the same way. So this is accepted. This is under work, and in the future, hopefully in the next Flink release, we'll have the great solution that will be basically solving the original problem without any evil hacks and limitations. So how much time do I have? Like for 5 minutes?
Sorry, we have 10 more minutes. It was a bug.
Okay.
Those sessions are longer, so sorry for the gong.
Yeah, so I have just a few words to say right now. We plan to have a support for other streaming systems, like Spark streaming is pretty much under work. So we have a Spark integration. It doesn't support Spark streaming right now, but it will in the near future. And good candidate, I think, is Kafka Connect, because it's kind of simple and it gives a lot of value to its users. So it's a great candidate to have. So column-level lineage support. We have a column-level lineage support in OpenLineage, in many other integrations, but not for Flink. And it's a hard problem, right? Because your data stream can write data to Kafka, but also can be transformed in any way you want. So we don't really know what happens in the transformations you produce unless you somehow notify us. And that might be the solution for data stream, but it's not for SQL, right? SQL knows exactly which column are being transformed to some other columns. And even if you do something like star, select star, Flink knows what the table is underneath. So we can resolve something like wild star to an actual columns, and then get the whole end-to-end column-level lineage. Unless you're using some UDFs that break those simple solutions, but there may be a solution to the UDF problem via some additional annotation. So yeah, native support for Spark connectors. Spark already has a similar mechanism that we use to view the internals of the job. And it works quite similar to what's proposed, but we have some also other issues, like the versioning stuff is not yet solved. And we have an interface merged ready, and we're working on Spark connectors, some Spark connectors to implement it directly, so that we know it will work for the continuous future, right? And another possible thing is like supporting for Kafka client, because for Kafka it's also kind of popular to build your own stuff rather than just use some other people's data systems. So there are some problems with that, like Bootstrap servers is not unique. We don't know if you connect it to the particular Kafka cluster or not. Yeah, and execution spread over multiple clients. So we have like a distributed system compared to single Flink job manager, but maybe not all of them need to report the whole data. So the most important thing is what we do is open source. So you can just go to our web page. You can go to our GitHub, open an issue, tell us about your use case, try it. If it doesn't work, you can complain on Slack, or you can try to fix it yourself and commit. And yeah, it's what we do here is, I think, pretty great. And hopefully, many people will find some value and contribute also. Thanks.
Thank you very much for the presentation. We still have 5 more minutes for the QA session, so are there maybe any questions for our speaker? If not, then I have to. Okay, first one, you've mentioned Spark on one of the first slides that it's one of the producers. Do you mean that all the systems that are built, let's say, on top of Spark, like Databricks, MS Fabric, etc., should have no problem to connect with OpenLineage, or are there any hidden tricks?
Yes and no. So if you're using something like EMR or Google Dataplex, by the way, Google Dataproc has native integration with OpenLineage, so it basically contains OpenLineage. You have to just go to their setting page and enable it. It works great, right? And there are like other systems like AWS Glue, Databricks. I don't know much about Fabric, so I can't answer there, but they often have some extensions or even direct changes. So if you're running AWS Glue, you're not actually running Spark always. And for Databricks, it's even more complex because they replace some execution classes underneath. So we like parse the Spark job. It looks like what we know, but then it turns out the class that we're looking at is not like save into some data source. It's Databricks Tahoe merge edge into something, and that's not open source code. We don't know what happens there. And if we encounter such issue, we basically try to fix it via this ugly solution reflection, right? So if you're running Databricks, we don't guarantee you that the experience would be as nice as you would use like open source Spark.
Okay, thanks. And the second one, does OpenLineage, okay, because OpenLineage is an open source project, but is there any enterprise tier or company that's, you know, just like for Terraform Enterprise, is there a way to get the enterprise support for OpenLineage, or do we need to find a consulting company that just specializes in that and supports us?
So I would say talk to us, and we can help you. There's no like big, I don't know, 1,000 people company behind it, right? It's not like you go to our page and the first thing is register in our SaaS. We don't sell something like that.
Okay, thank you. Anyone wants to ask? Ah, sorry, I haven't seen that. Sorry.
Okay, I have a question. Are there any actual business cases that were solved with this kind of data lineage, streaming data lineage, with the cases that you could share with us?
There are some cases, such cases, and I can't share it with you, sorry. The company doesn't want to talk about it.
Okay, so the second question. You mentioned at the beginning of the presentation that you base the data lineage on the metadata, and you prefer, if I understood correctly, you prefer to use the internal metadata, so if there are any gaps in the metadata, do you stick with it, accept that there are gaps? Yeah, yes, this one. Or do you try somehow to fill the gaps, maybe with the use of AI, for example?
So I would say there are two things here. First is that the database always knows what data it has. Or like if you read data from some table in Spark, that Spark knows that it's reading from this table. So it's like the most fresh data we get. But of course, there are some gaps. And I think the solution lies on the other end. Instead of trying to like force the OpenLineage to be something it's not, the like consumers of OpenLineage, like Atlan, have other APIs that you can like manually create some data or use some other data source until OpenLineage like covers all the cases, right? So I'd say it's like the solution on the right side here. It's not necessarily solved with OpenLineage.